Hello everyone. Today we're going to talk about double hashing. So far we have talked about bucket hashing, linear probing, quadratic probing, and that are some functions or some ways to do the closed hashing or open addressing. Now today we're going to talk about this double hashing that also is a fix to the problem of the quadratic probing. So the general format or form for the double hashing is this one that you see here. So let's say we have the function hashing function h of some key k is equal to some like function h1 of the k plus I h2 k. So we have two hash function here. So it's like a lot of things are similar to what we said about like the quadratic linear probing, that whenever you have some keys, you just calculate the values based on the hash functions h1 and h2 here that you have here, and also the key. And if there's some collision, then you're increasing I, and it's gonna give you the new values for the hash function, this h that we have here. So there might be some issues still with this double hashing. Okay, that is, if for some keys, let's say k1, so if the h1 of k1 is equal to h1 of k2, okay, and also the h2 of k1 is equal to hash function 2 of k2. If this is the case, then still we will have some issues, okay, because we have these two keys here. Let's say we have already inserted key k1, k subscript 1 in the table, and now because the hash table 1, hash function 1 and hash function 2, okay, both for this keys k1 and k2 are giving the same values, okay, then we won't have some issues on inserting and finding a spot for the key k2. But if let's say that we have this hash table with the size m, okay, so if the hash value that is generated by the function h2 of k, okay, is some value, if the m is a prime number, so we are assuming that m is a prime number. So if the hash function that's hash value that's obtained by h subscript 2 is a number between 0 and, so let's write it here, h2 of some k between 0 and m minus 1, okay, not including 0, then we're gonna be okay, because it's will give us it will gives us some numbers that are not they don't have a collision with the value, for example, at location k1.